Today we're going to talk about some of these other air pollutants other than carbon dioxide. So this is maybe a little less detailed. It was something that I'd hoped to expand on a bit more, but it's kind of just running out of time for the semester. And some of these things do overlap with some of the concepts we talked about as well. So that's kind of why I limited it. Maybe in the future I'll talk a little bit about the ozone layer as part of this course, but yes, like I said, ran out of time. So let's talk about what these other major air pollutants are. There's a whole bunch of them out there. This is a little infographic that kind of outlines some of the major ones. So we also have carbon monoxide. We have a lot of these nitrogen oxides, which are really important. And these ones are from combustion in automobiles. And so that's something that we're concerned about sometimes in terms of cities and pollution, and when you have more automobiles on the road and those kind of things. Sulfur dioxide, this is sometimes associated a bit more with industry than automobiles, but dealing with combustion in general as well. Also associated with coal generation power plants. So I'm not sure if we have any coal electricity in Alberta. My hometown used to have a coal plant back in Ontario, and they had some sort of process for using low sulfur coal. I don't know whether that's a special coal you get from someplace or whether the coal is pre-treated. I don't really know much about it, but that was one of the concerns, is to reduce sulfur emissions as part of their pollution. But it's no longer a coal generating plant, so couldn't tell you much about it. It's now converted to biomass, which is kind of an interesting story on its own. One of the other ones that I want to talk about in a little bit of detail is these particulate matters. So I'll talk about them. I think I've got a whole actual slide on them as well. And not really going to talk too much about ozone, but it is a pollutant at kind of lower elevations. It's good high up in the atmosphere. You probably know it filters out the UVC radiation and actually protects us from sunburn and cancer. So it's good to have ozone in the upper layers, but not so good for humans in the lower layers. So there's some other pictures, I guess. There's some structures. I know next year you're going to take organic chemistry, so you're going to learn all about these structures and a lot more about these. So like I said, I want to talk a bit about particulate matter in particular, and I think I have an actual slide on it, but particulate matter kind of just means larger chunks, and there's different ways to define them in terms of the size and those kind of things, but often you look in a lot of organic compounds. Also, those polycyclic aromatic hydrocarbons we were talking about before. So if you remember these here, we talked about them on the last test. And I had mentioned they were maybe even more important in air quality. And they're basically from organic things that are being combusted. So it could be forest fires, could be a grilling of food, et cetera, et cetera. So this was something that the matter was very high in the air during the wildfire we had in 2016. And I have a little bit of information on that wildfire as well today. So yeah, this is just kind of a chart talking about some of the things I had just mentioned and connecting them to human health effects. So you probably know that people with asthma in particular sometimes have issues when the air index is high. And I'm going to talk about that air index in general, but probably no surprise that when the air quality is not good, you're looking at respiratory problems. So people with asthma are probably more susceptible, or people with other chronic respiratory issues, but it will also lead to reduced respiratory function in most normal individuals as well at high levels. The wildfire was very interesting because I don't have asthma, but I do remember the days leading up to it. People with asthma were complaining more, but I can't remember what day it was. There was one day where I felt it. I felt it in my throat, and I was thinking, wow, this is getting real. This is getting serious. But like I said, probably no surprise that you're looking at respiratory issues. but it can affect other tissues, depending on which chemical you're talking about. If you look at these volatile compounds here down at the bottom, you can see that some of them are carcinogenic, and so that's never good and can affect other tissues as well. Environmental effects, of course, these things can have environmental effects. They're getting in the water, they're damaging plants. Those are kind of some of the big issues that we're talking about. So where are these pollutant sources coming from? Some of the same things we talked about before, right? So, wildfires, you can see is on that list. Things like volcanoes. You're looking at industry, so you can see right here, this is all industry, homes, those kind of things, transportation vehicles, and so on and so on. And some things actually come from animals. So I think we mentioned methane, for example, is something that comes from cow burps, and you've got other volatile compounds that kind of get emitted from agricultural processes. So I kind of have a little bit of a slide on each of these, just kind of a summary of looking at them. So like I said, nitrogen oxides are a big one, and you're looking at automobiles, trucks, buses, whatever, are the biggest source. And that's something they talk about a lot when they're producing new automobiles. I don't actually know a lot about automobile industry and so on, but it is something that is talked about as a major pollutant. And as they make engines more efficient, they're also looking at emissions as well. I think this is one of the main things. I used to live in Ontario, I had mentioned, and in Ontario, I don't know whether they still make you do it, but there was this emissions test. And when I was there at the time, I had an older vehicle which failed the emissions test, and I think this was one of the indicators on there. It had failed the nitrogen oxide emissions, so it meant that my car was a big polluter, so I had to get it fixed up. Sulfur oxides, you can see we're looking at different types of industrial sources here, are the big ones, different refining industries and so on, and it can be a cause of acid rain. Volatile organic compounds, oil and gas, again, no surprise, we've got industries making these things. And the fine particulate matter, so this is the one I want to talk about in a bit more detail. You can see they're talking about the size here. Now, I can't remember if that's nanometers, what the size is. I'd have to look that one up. But you can see we're looking at firewood burning being a big one. And these particulates that are just made from people burning stuff or grilling food, or forest fires is another one as well. So here we go. Okay, it's micrometers. I can remember it was micrometers or nanometers. You're wondering what you're looking at. So this is the one we were just talking about. But often you'll see in these air quality index reports, they might be talking about different sizes of particulate matter. So you can see you've got these two over here on the right. These are larger sizes. So these are, kind of about the size of pollen. And so things that are smaller than your eye can see. So the human eye, by the way, has a limit of about 100 micrometers. That's about the thickness of a human hair. So we're looking at things about, 1/10 of that size. The fine particulate, you can see, is about the size of maybe a red blood cell. And sometimes you see this index here where it's talking about the ultra fine particles. And so these are 0.1 micrometers and a little bit smaller. So that's about 100 nanometers. So all these things, they can get in people's lungs and they can cause issues, particularly in high concentrations. So I'll show you, I think the next few slides are talking about the air index. Not quite yet. Forgot about this one. Lots of these studies done by NASA and whatnot with these cool satellites, and you can see this one is showing the particulate matter index of different parts of the world. So I don't really know exactly why it is so high in this region. Again, this probably has something to do with climate and weather and air conditions, and obviously you've got some populous parts of the world there. You've got India and parts of China covered there. And those are big polluters as well. So like I said, I don't really know a ton of this, but if you take a look, this says dust and sea salt is removed, and you're still looking at India. And I think that's parts of China as well. I'll have to check out my map just to make sure I got everything correct. So probably no surprises there as well. So this is apparently Canada and the US. And so probably, again, no surprises. You can see the this sort of yellowish color, right? So you're looking at populous industrial regions of Canada, kind of also there. I'm guessing not as much in the Maritimes in terms of and in the West Coast, not as much industry.
Looks like there's a lot in the Midwest for the States too, and towards New York.
Yeah, yeah, and this whole region in the U.S., right? There's tons of industry there. Plus, the population density is huge, so you can imagine all the sources of it, right?
There's about I think in the States, I heard this like 300. It's like 330 million people for the whole country.
Yeah, something like that. Pretty much about 10 times out of Canada, roughly. And
But that's just the mainland. That's like the states, but like not including like the
yeah,
territory they own.
well, the state of California is approximately the population of Canada, which is kind of crazy.
It's actually bigger.
Is it?
It's
Yeah,
about so Canada's population's about 36 million, 37 million now
yeah.
probably. And California is about 42 million.
Okay, yeah. Well, I
It's
say we trade.
actually it's interesting. California is a bit interesting because they're saying that it's so like I read that like it's so densely populated that that some people, the scientists, think that it's actually sinking.
Huh. Yeah, well, they're having issues with water and drought as well. That I believe may have um, something to contribute to it.
Oh
With
yeah,
the
like
withdrawal of
dams and stuff like
groundwater.
that. Like
Yeah.
oh yeah, they built a lot of dams. Like
Either way, I
that's
wouldn't
why.
mind trading. You know, the Californians can move up here, and we'll take California. I wouldn't mind that.
Although fun fact about Canada, so so let's rush this a little bit bigger, but for Canada land wise, like we have I think the highest percentage of unclaimed land.
Yeah, I would believe that. We have a lot of land, a lot of areas that are, well, I mean, it's just we've got a lot of northern climate areas, right? That are
Yep.
not going to sustain agriculture and whatnot.
Yep.
All right, so let's take a look at some emissions by sources. And you can take a look. This is just a graph showing some of these emissions, right? So you can see we've got PM10 here. Oopsies. PM10 here, PM2.5 there, sulfur, nitrogen, VOC, and so on. And so if you look at these numbers overall, you know, you can see some of the big polluters of PM10 is agriculture, and the PM 2.5 also agriculture. So like I said, you've got a lot of volatile things that are coming off from agriculture. I was just looking for the oil and gas industry is big over here on the sulfur and the nitrogen. So I don't know a ton about these industries in terms of, you know, the pollutants and things like that, but probably no surprises in terms of that they are polluting. We know that. Question is, you know, what we can do better, obviously. So here's the good news. The good news is the trends are going in the right directions, pretty much for all of those measurable elements. We have greener technologies, we have stricter environmental laws, and more efficient mechanisms that are you know, helping with this kind of thing, right? So this is all good. I always wonder though, you know, can we do better? And you know, is there any area that we should be really focusing on? And it's a question I don't really know the answer to. And all this air quality stuff is relatively new information for me. So human health, this is something that the World Health Organization talks a lot. If you look at some of these countries that have poor air quality, there are people dying from outdoor air quality. And so here's some numbers from World Health Organization. They're estimating about 4.2 million deaths globally. And this is from outdoor air pollution, and 3.8 million due to smoke. So a lot of people have wood stoves in their homes worldwide. And of course, that does create smoke and can lead to respiratory issues. And there are ways to make smokeless stoves, with chimneys and things like that. A lot of people just don't have them. I was watching, trying to remember what it was I was watching. It was a little documentary on, I was thinking Nicaragua, but I think it was Honduras. And there was a group in there going in and surveying cooking conditions. Honduras, if you don't know much about Honduras, it's a very poor country, economically, and people are they're just making do, right? And this organization was going in and actually, I can't even remember which organization it was, but it was gifting people these smokeless stoves that were properly vented and all that for the homes for this reason. I don't remember too much about it, but it was an interesting story. So you can see we're also looking at things like lung cancer, stroke, and heart disease. I don't know if those numbers are accurate or not, but 36, 34, 20% of deaths. But we know that air quality is an issue. And there's a lot of discussions I noticed in the news the last couple of years about people having natural gas stoves in their house. There's been some interesting studies on how much pollution natural gas stoves actually for cooking cause. All sorts of these toxic compounds, and not good for breathing. Whether you have one or not, if you have one, I just advise you put your vent on while you're cooking at all times. Okay, so let's talk about these air quality guidelines. You can see there's some guidelines for these pollutants, right? These different values, and so these are things we look at when we are trying to have guidelines. And the one that you might be familiar with, I think I have it on the next slide. Hold on, but I'll be back to that in a minute. You might be familiar with this Air Quality Health Index. This is the one that's reported on like the Weather Network, Environment Canada, and they have this scale basically from 1 to 10. I'm not sure what the scale got to with our wildfire, but you can see
it was I think it was pretty high because
well,
because it was enough that like the state of Connecticut declared an air pollution thing because when the wildfire happened here, so
yeah,
the total size was the burnt was the size of Prince Edward Island,
yeah.
and all of that smoke, you know how smoke
Well,
travels fast, right?
I think the evacuation day was on a Tuesday.
Yeah,
And just to tell you
yeah.
where we were at, on the Monday, my son had a soccer practice, and we weren't sure whether it was going to run or not. And that Monday morning, I think it was around a 6. I'd never seen it that high before.
Yeah,
And
we were okay. They
just let me finish
compared.
my sentence here.
Sorry,
I was just
sorry.
going to say the plan was to cancel the practice, but by mid-afternoon, the wind had changed directions and it went down to a 2 or a 3. And so the soccer practice went ahead on that Monday evening. And then, of course, the next day it was the opposite again, right?
I remember that Monday evening we had ash falling. Like ash was falling on our car, on people, on the cars, and that.
Yeah, it was a crazy
It was
time.
So you remember the BC wildfires a couple years ago, right?
Yeah.
They were comparing the pollution levels from the so our pollution levels, like I think worst case when they had that, like they were comparing it to Beijing, China.
Hmm. Yeah, yeah. Well, I think I'd mentioned before I had a friend that lived in Beijing for a couple of years, and she said there were certain times of the year you just didn't go outside. And when you did, she wore a mask. So
You
this
had
air
to
quality
because
index, I'm just going to skip back to a few slides, but I just wanted to say you can see it's these kind of the usual suspects. We're looking at particulate matter is the big one, ozone and nitrogen dioxide. I don't know who came up with the formula, but there's the formula if you're interested in it. I'm never going to ask you to calculate it. It's just a punch the number kind of formula. but you can see that it is a variable in there. I'm just going to skip back up here to this. So we have these air quality guidelines from the World Health Organization, and Canada in particular has their own guidelines. I haven't actually looked to see how they compare. I think they're relatively similar. And you can see, I was just going to point out that there's kind of annual and 24-hour guidelines. So they understand that sometimes in certain seasons it's going to go up. And so what they're looking at is a guideline to, an average one over the year as well. So Alberta does have their own standards or objectives as well, and you can see some of them are there. This is just part of the list. You can see this is not even covering the full letter A, but kind of same idea. You've got concentrations and parts per billion and whatnot, and based on the information. So I just to follow up on last day, I think it was Fahad who asked about part per million. So you may remember with our liquids, parts per million is milligrams per liter. And I think he was asking whether parts per million was the same for gases. And I kind of have an answer to that. I tried to do a lot of searching, and I actually asked a couple of air quality specialists, and I kind of got different answers. But my understanding is for air quality, they're actually looking at volumes. So if you remember your high school and first year chemistry, the gas laws, and so you can look at how much you sample, let's say 30 liters of air, and how much in terms of how much volume of, let's say, CO2 is in there. And that's how they're looking at parts per million. And that's my best understanding. I could be wrong, but just from looking into it yesterday, that was what I found out. So it's slightly different, but it's usually measured by these sensors that bring in the particles. Okay, so there's tons of information out there. One thing I found when looking at air quality is there is I was so overwhelmed with the amount of information out there and just public domain data in terms of in Canada and the world and all that. So I'm just going to focus on the local air sampling, and this is done by WBEA. So WBEA is the Wood Buffalo Environmental Association. So you may have heard of them, and we've had at least a couple of students from here and go and work for them. Sometimes they hire students, so you can always check with them if you're looking for jobs. I'm not sure if they're hiring this year. I know they didn't last year because of the pandemic, and it's just complicated to train people and whatnot. But you can always check with them, and they have a website. So what I wanted to do is just kind of take a peek at this website with you to show you what kind of data you can get. I'm just clicking on the website. I guess I got to share my web browser. So there it is, and you can see they have this map here of all the stations that they have out there. There's different types of stations. They're color coded there. What's the scheme for the blue cloud? Are there continuous sites and so on? So how do I zoom in on this? It says hold control. Is this going to work? Oh, there we go. So there's Fort McMurray. You can see there are sites all over the region. In Fort McMurray, we have 2 sites. And so one of them, oops, there we go. So one of them is in Timberlea and one of them is downtown. And we're working on setting up something at the college as well. I don't know whether it's connected into their system yet. I don't know if you guys have an answer on that.
Yeah, I heard, I guess it's true. I learned of this when our flood happened, Blaine.
Mm-hmm.
But I don't know if I mentioned it, unless I did. But I thought it was interest in how the hospital has their own system that's not connected to the water system in the city's water system.
No, that is interesting. Yeah, I guess it makes sense for emergencies, right? Because they are a crucial piece of infrastructure, right?
Yeah, and it does make sense that they have it for even not emergencies too, because it's the last.
Yeah, no, it's good. So this air quality station, if you take a look at the map, you may see it if you're driving to Mac Island. It's just kind of along this road, just near the bridge there. So take a peek, you might see that sometime. But you can click on this station data. This is all publicly accessible data. So Wabia is basically, there's a picture of it.
That's
I don't,
actually that is oh, I know where that one is.
yeah. You just
There's
drive by it.
actually that's the one by Mac Island, but there is actually another one at the Synchro Athletic Park.
Yeah, so you can, yeah, that's where the other one is. Yeah. So you can actually see the data and access this data. Wabia is a nonprofit organization, so they make all their data publicly accessible, and you can watch. I've taken a few looks at this kind of thing. You can see the spikes go up and down during certain times of the day of the different compounds. So, for example, I'm looking at um, nitrogen dioxide here. So I'm not sure why. I guess it goes lower. What is this? 1500. That's 3 o'clock yesterday. I guess I was expecting it to go up around 5 or 6 o'clock when everyone gets on the road, but it seems to go up in the evening. So maybe there's a bit of a delay between people driving their automobiles and it getting into the air and detected by the sensors. But anyway, if this is something you're interested in, check out their data. They've got lots of interesting things going on here, and I'm just beginning to poke around and understand it myself. All right, so this is showing, you can see summer and winter. So winter is on the left and summer is on the right. And again, I don't know a ton about weather and climate, but you can see that the numbers of the amount of nitrogen dioxide is higher in the winter. So I don't know whether that's because people are driving more or because the gas just doesn't disperse as well at lower temperatures.
I think it's because it's that's like I think the red is heat source. Like you know how it gets very cold.
Well, this is but this is measurements of nitrogen dioxide. So it's just showing that the concentrations are higher
Yeah,
in the
it's because
populated areas.
it's because I think it's because like in the wintertime, like factories and that they put out more.
Well, and yeah, I guess, and your automobiles are working harder as well, right? So,
Yeah,
people are leaving
and
them
it's a
idling. People leave them idling, people to warm them up for 10, 15 minutes, some people,
yeah,
and so on.
and also Blaine, think of household warming, house heating too,
Right.
like
Yeah. No,
furnace
good call.
systems.
Yeah.
Yeah.
Yeah. Good call. Yeah. So, yeah, probably a bunch of factors, but something I'll have to look into. So just skip that slide. So there's our air quality health index. Like I said, this is what you see on the Weather Network and Environment Canada and all that. And you can take a look if you go to, I'll come back to that slide in a second. This was actually not today. This was Monday. And you can see that the index on Monday was a 2. And you can access this. You can see this is right from weather.gc.ca. I can't remember if that's Environment Canada or something else. I thought I saw that on the Wabia website as well. So there's lots of places that have this index that's published. And so a 2, what does that mean? And they have this little chart, and you can see that 2 is a low risk, enjoy your usual activities, ideal air quality. So that's good. 4 to 6, reconsider doing strenuous activities. Most people will be okay, but some people with respiratory issues may feel something. The high risk is where we're starting to look at exactly that high risk. And so they recommend children, elderly, and people with asthma avoiding going outside and whatnot. So, like I said, when we did the wildfire, I'm pretty sure the one day before the evacuation, it got up to pretty high. It was 6 or 7. I can't remember if it got up to the red or not, but I was certainly starting to feel a tickle in my throat. And
Yeah, it was
worse.
I think although the day of the evacuation it was definitely very high. I remember so like I remember when that night when we were driving back, we drove back to town.
Mm-hmm.
Like even with the proper ventilation in the car, like I was definitely some little trouble even especially when we got to the bridge that night.
Yeah.
Because when we were we were so It's interesting how it didn't jump across into downtown, but
Yeah.
when we were driving through that night, through town that night, like the downtown, we were, they have, the cliffs you can see along towards the highway.
Sure.
Those were all lit up.
Yeah, yeah. No, yeah, I'm sure everyone has all their stories, eh?
Yeah, but yeah, it was definitely hard to breathe. But like we've had like
Yeah, I
this
wish I
summer,
had, I don't know if I can find historical data on what the air quality was. I'd love to see the numbers for when the fire was at its worst in terms of this air
yeah,
quality health index. I bet you
yeah,
the numbers are out there
last
somewhere.
yeah, last summer and the summer before, we seem to have a bit of a break with the high amount of precipitation we had.
Yeah, yeah. Anyway, moving on. I just want to get through this. Um, Couple other things to say. So you can see, by the way, this is just a chart showing exceedances of these, right? And how often that happened. And so you can see some numbers here. And this is at Wabia. And so if you take a look, 2016 was, of course, the wildfire. And you can see that the numbers got pretty high on some of them. So let's just talk a little bit about wildfires for a minute or two. Wildfires are well studied. They are something that happens all over the world in many places and many times. And you can see there's a little infographic here on some of the chemistry of wildfires and talks about some of the stages and whatnot. But if you take a look at what this is talking about, and this is one of the things I'm looking at, products, what is being made by wildfires, and so on. And of course, you're looking at a whole bunch of different pollutants. So particulate matter, nitrogen, carbon compounds, and so on and so on. And of course, this is contributing to huge amounts of pollution and other things. Um, and so this is something we're obviously very concerned about, especially after having a couple of big ones in Canada in the last 10 years. So you probably know that the wildfire we have has been named the Horse River wildfire. I'm just looking on this map. I don't know if this map shows the Horse River, but this was the area it was covering. So
Yeah,
big
the
areas
start.
around Fort McMurray. Yeah.
Yeah, the starting point was, I think this the start. Does the Horse River go back to towards where the where the recycling
Yeah.
place is south of town?
I can't remember which one's the Horse River. I was thinking it was attached to the Hanging Stone River, but I'm not
Yeah,
entirely sure.
where the there's a disposal place south of Gregoire.
Hmm.
It was about it started in the woods behind there,
Yeah, yeah. So that
and
I don't even.
the Horse River. So the Horse River actually, it's actually where the Horse River floods out. It's actually by it floods out further. It floods into the Athabasca River further, just a little bit past or before the water treatment plant.
Yeah, so I'm actually just looking at a map on my phone. The Horse River connects to the Athabasca,
Yeah,
and just trying to think if that's the one last spring I hiked to it. You can get through it kind of if you go up to Abisan, and there's a way to hike down to it. And I was
yeah,
at the area where it meets the Athabasca.
yeah, yeah. I went to I took plant ID
Hmm.
last term, and we actually did we took a field trip out behind Abasan.
Oh, nice, nice.
Yeah, it's a fairly steep incline climb down there, but it's very beautiful.
Oh yeah, yeah. So there's been quite a bit written on the Horse River wildfire now. I'm just going to share a little bit with you if you're not familiar with it. This is kind of some of the stats. So all of the region was evacuated. There were a few essential personnel remaining behind. A lot of people don't realize that there were a few people that remained behind as essential personnel, and the water treatment plants each had a few people staying there because otherwise they would have had to shut the entire thing down, which would have been really bad. Um, about 2,400 structures destroyed and has changed the city significantly. This is from a paper, and it's very detailed and very technical. And kind of this is just the highlights, is that there were, no surprise, elevated levels of most of these pollutants. And you can see some of the numbers here, right? So you can see the maximum, so the mean particulate matter was about 293 micrograms per cubic meter. And the max, it got up to about 3,500. So that's really, really high in general. Not good to breathe that stuff. So that is about it for the air quality stuff. And the course. I just want to talk about the exam for the next, I guess, 15 minutes, and do a little bit of review. So there's just a summary, and I know I have some other study questions and whatnot, but I'll let you take a look at that on your own time. All right, so just give me a moment here. I'm going to switch over to my other PowerPoint. Okay, so let's talk about the final exam. I mentioned I'm going to do an extra review, and that's going to be tomorrow. And I'm going to do a lot of calculations tomorrow. So extra review is tomorrow, so that would be Thursday. I don't know what today's date is. So tomorrow is Thursday, April 15th, and that will be at 10 o'clock a.m. And so just use the class link for Zoom. And I'm going to be doing lots of sample problems. And if you have any questions to bring, or if you want me to focus on something, then certainly let me know. Some of the areas I might skip over quickly, and if you just need me to slow down or speed up, I'm always open to that feedback. So by the way, Calvin and Hobbes is one of my favorite study tools, or at least study breaks. And I may have changed one or two words on this particular cartoon, but you can see he's saying, "Have you studied yet? I'm waiting for inspiration." And
oh yeah, Calvin and Hobbes is
can't just turn that on. You have to be in the right mood. What mood is that? Last minute panic. So hopefully you guys are not taking the last minute panic approach to studying for your finals. So like one more joke for you. I just saw this on the internet. I thought it was fun. This is not going to be the case, by the way. So one more joke for you. So this is the details of the exam. It's 100 marks, and 25% of your final grade. It's going to be a combination of most of the types of questions you've seen before. So multiple choice, fill in the blank, true, false, calculation, short answer, and so on. And it's going to cover the whole course, although there'll be a little bit more emphasis on the last few units that you haven't been tested on. But definitely you do want to study for the whole course. So this included 11 topics, and so there they are. So make sure you review all the topics, and make sure you do take a look at these review slides I have, because what I've done is in these review slides, I've gone through and kind of looked at each of the topics and pulled out what I think are kind of the major concepts. And a number of these units, I do have calculations. And they're very similar to what you've seen on the tests. The only difference is sometimes, I ask you to do it the other way around. So if you think about, for example, pressure calculations, right? So rather than asking you what the pressure is, I might ask you what the height is instead. So be prepared for that kind of thing. The other thing is, I will be asking some questions relating to the labs. And so do make sure you do review your labs, although the concepts are pretty intertwined. But there are a couple of things, and I have in these review slides some reminders of some of the things that were a little bit more unique to the labs. So notice this one here. It says know how to manipulate data and explain results. So I'll show you some sample questions here eventually, but the type of things I'll do when looking at the labs is I might show you some rough data and ask you to calculate something, or I might show you a graph that you would have produced in, let's say lab 5, and ask you to interpret it, or some other question around that. So just be prepared to know a little bit about your labs as well. Okay, so where are we with time? Okay, about 10 minutes left, so that's not too bad. We'll start right at the beginning. And like I said, I have a slide on each topic. And I kind of want to talk about these and do some sample problems. So this is how tomorrow is going to continue. If you're very comfortable with the calculations, you don't need to attend tomorrow, but I'll do it for the benefit of anyone who wants to go through some of the sample calculations again. So topic one was kind of about general knowledge about water distribution, Alberta water resources, and kind of finished off talking about physical and chemical properties of water. So that's the water molecule, of course, and this here is representing two different types of bonds. So this is a covalent bond. And just to kind of maybe add to that, I would call that a polar covalent bond. As you can see here, we've got these partial charges. And this one here is called a hydrogen bond. So make sure you know what a hydrogen bond is. By the way, you are going to see hydrogen bonds in organic chemistry, so it's worth it to know a little bit about them. I'm not going to focus and ask you what a hydrogen bond is in this class, but it's basically a strong dipole-dipole interaction. You can see we have this negative and this positive over here. That's kind of what you need to know, that it's an important part of giving water its physical properties. We also talked a little bit about the water cycle. I'm not going to ask you questions about the water cycle. That's kind of, grade 7 or whatever. Water uses was another thing that we did talk about at kind of the back end of the course here. So let us review the metric system. So I made this little table to kind of go through some of these things. We didn't use all of these things in this class, but I kind of made this table to kind of review what I think are some of the important things just generally for in science. But many of these we did use. So if you take a look at this, we've got the mega. Mega is a big M, and we certainly talked about megaliters. So that is 1 million liters. Kilo is 1,000. So we talked about kilograms. We didn't use kiloliters, but we talked about kilograms for sure. And that's 1,000, right? So you can use a big K or a little k for kilo, by the way. I don't know if you guys knew that. Either are acceptable. So centa is kind of the odd one here. It's not a multiple of 3, but we do use centa for centimeters. So centimeter is 1/100th of a meter, so 10 to the minus 2 meters. Milla is 1/1000th. So we talked about milliliters, of course. And micro and nano, I'm trying to remember if we use those in this class or not. I use them all the time when I'm talking about microscopy. But if I do give a micrometer or a nanometer or something like that, I will define it because not everyone is necessarily familiar with those. So let's practice some conversions here. I have a bunch of calculations here, and what I've done is kind of broken these out to different slides. Remind you how to do some of these metric conversions. So let's take a look at this one here. It says convert the following to milliliters. So if we want to convert this to milliliters, it's times 1,000. And that's going to give me 12 milliliters. So if we're converting from liters to milliliters, it's divided by 1,000. And that actually gives me 12 milliliters. Wait a sec, did I do, no, that's correct. Sorry, that should be times 1,000, yeah. I knew I was doing something wrong there. So that's just the same way to represent the same number, just a reminder about scientific notation. So microliters, sorry, is divided by 1,000. I was just getting ahead of myself. And that is 12 milliliters. So you're probably seeing a theme here, right? Going from megaliters to microliters, that's going to give me 12 milliliters as well. All right, B. So what is B? Convert to liters. Okay, here's where people start to get messed up with things in terms of what all of these are. So a ton. Remember what a ton is. A ton is equivalent to cubic meter. Okay, 1 cubic meter is 1 ton, right? So if I want to convert this to liters. So remember, 1 cubic meter is 1,000 liters. So this is basically 41,000 liters. So I just gave you the conversion here. So this is 4,100 liters. So this is a good conversion to know. The other good conversion to know is that 1 liter equals 1 kilogram. So that's the other conversion to know. So in this case here, that would be 410 liters. And then the last one is grams. So last conversion to know is 1 gram equals 1 milliliter. So this here, I'm converting to 41 milliliters, which, and then I divide it by 1,000, 0.041 liters. I could have used a different conversion. I could have used this conversion here first. It doesn't really matter which way you get around it. So make sure you're comfortable with these metric conversions, particularly these 3 boxes are good things to know for making your conversions for water. Now, what was C? C is convert to grams. Okay, so remember that 1,000 grams equals 1 kilogram. So that means that this will be 23 grams. And remember that 1 gram is 1 milliliter. Okay, so that means that this would be 23 grams. Okay, so is that last one 23 grams? No, because remember that 1 kilogram equals 1 liter. So this here, if I convert to kilograms, that's 0.23 kilograms. If I convert that to grams, that's 230 grams because I'm multiplying by 1,000. Last one. Okay, so last one, I kind of run out of space here on this. Maybe I will squeeze it up here at the top. So 2.3 times 10 to the minus 8 cubic meters. So I'm going to convert that. I'm going to do this in a multi-step kind of thing. So remember, we have 1,000 liters is 1 cubic meter. I guess I could have converted that to tons as well, but I'm just thinking this way in terms of water. So 1 cubic meter is 1,000 kilograms. And then 1,000 grams per 1 kilogram. And so my answer there is 2.3 grams. So right here, 2.3 grams. Okay, so I know I blew through this really quickly. I'm just hoping everyone is relatively familiar with making these metric conversions. If this is something that you do have struggle with a little bit, please do let me know, and we can do some sample problems at a slower time. And like I said, I think last day, we can always make an appointment and do some office hours one-on-one if you need help while studying for the exam. Question, comment?
Pretty good. I was just that's pretty cool. I guess in the state, I know that in the States they use the imperial system.
Of course, yeah. I just wanted to show you guys something else here. Before I let you go for today. So if you take a look at these PowerPoints that I've posted for review, I do have the answers in them, right? You can see the answers are down here in the notes section. So they're not on the slides themselves, but they're down here in the notes section. So anyway, that's, I think, where I'm going to finish today. Like I said, tomorrow I'm going to do review these slides. If I don't see you then, I will see you for the final exam. Certainly have enjoyed talking to you folks this semester, and I'll definitely see you around the college, if not at the final exam.